Welcome to the video. My name is Pushpinder Gill and this is my email address where you can send me your valuable feedback. So today we are going to do the second video on data sufficiency, wherein we'll be talking about two answers data sufficiency question. The questions which has two answers, or most oftenly called yes and no data sufficiency problems, right? So I hope that you've watched the first video on the data sufficiency, wherein I explained all the concepts about the data sufficiency, how to solve such questions, and what is the basic premise behind it. And in the end of the video, I explained that there are two types of data sufficiency questions. So we're going to do the first type of data sufficiency question, that is a yes and no data sufficiency question. So if I ask you a question, am I taller than you? Then you can give me two answers, right? Yes and a no. And both the answers are giving me answer, right? So there can be yes, there can be no, and there can be maybe. Hey, maybe I'm taller than you, maybe not. So these two answers would definitely tell me that am I taller than you or not. So these kind of questions have two answers. Let's suppose questions like is my name David, or do I know GMAT? Yes and no. I'll get a yes and a no. So these kind of questions have two answers. So here what's the GMAT comes, the trick starts here. Let's suppose if I ask you, okay, is x greater than y, right? So if one of the statement is telling me that y is greater than x, that means the statement is sufficient because it's giving me no as an answer, which can also be taken as an answer. Alright. Similarly, if the second statement tells me, okay, x is greater than y, that is giving me yes as an answer. So both the statements are sufficient here. Why? Because no is also considered as an answer and yes is also considered as an answer. However, if you get a maybe, then the statement is not sufficient. So there are three possible scenarios that can come out of these kind of questions. Yes can come, a no can come, a maybe can come. So if yes is there, that means the statement is sufficient. If you get a no, that means statement is also sufficient. However, if you get a maybe, that means the statement is not sufficient. I hope it's clear to you. On these kind of questions, there are only three answers: yes, no, maybe. If I ask you, okay, is your height greater than 168 centimeters? Then you'll say a yes or a no or a maybe. So if it's a yes, that means definitely yes, you gave me the answer. No also, you gave me the answer. Maybe it's not the right answer, because then it can be yes and it can be a no, right? So this is what a simple yes no data sufficiency question looks like. Is this condition true? That means, is x greater than 0? The statement looks like this, right? Then the first statement says, if this fact is true, then is this condition true or false? It will tell you x is greater than 5. If this is true, is this x positive or not? Yes, x is positive because I'm getting a definite yes, right? In the second statement as well, it will tell me if this fact is true, is this condition true or false? I'll say x is greater than -2, but x is less than -1. That means yes, I'm getting no as an answer because x is a negative number, and I'm trying to find whether x is a positive number or not. So I'm getting a definite yes here, I'm getting a definite no here. That means my statements are sufficient, right? So what trick is used here is, even no is considered as an answer, alright? However, a maybe will not be considered as an answer. So what exactly this maybe is? Maybe means you get a yes and you get a no as well. So both can come. Let's suppose if I give you the statement that x is greater than -2. So if x is greater than -2, can you be sure that x is positive? No, because x can be let's say -1 as well, and x can be 1 as well. So over here I'm getting a no, and over here I'm getting a yes. That means that there is an ambiguity. So whenever there's an ambiguity, that means I'm not able to get the answer from that statement, right? So I hope everyone understood this. So try to disprove the statement by getting a value which gives true for the statement and a value which gives false for a statement. So whenever you're trying to solve a yes no data sufficiency question, always try to disprove the statement. So how can you disprove a statement? Is by getting a maybe. So how do you get a maybe? By getting a yes and getting a no. So once you have both of that, okay, once you have a yes as well, once you have a no as well, that means the statement is maybe. If the statement is maybe, that means that statement is not sufficient at all. So I hope till now the premise is clear, and till now the strategy is also getting clear to you guys, that for every statement try to get a yes and try to get a no. If you're able to get a yes and if you're able to get a no, that means that the statement is not sufficient. However, if you get only yes and only no, that means the statement is sufficient, right? Alright, so let's see this question here. Let's try to use the premise in this question. Now what do I have to get? I have to get a yes and I have to get a no. If I'm able to get a yes and a no, that means the statement is not sufficient. So he's asking me, is x greater than 0 or not, right? Over here modulus of x is greater than 0. So we have to meet this statement. This is the fact statement. If this is true, is this true or not? This is what the author is asking you. So make this true first. Let me say x is equal to 5. If x is equal to 5, this is true. Modulus of x is greater than 0. Is x positive? Yes, x is positive. So I'm getting a yes. Try to get a no. Let's say x is equal to negative 3. Any negative number. Minus 3. Modulus of minus 3 is greater than 0. Is x positive? No, x is not positive. So I have got a yes and I have got a no. No need to think any further. This statement is not sufficient, right? So you get a yes, you get a no, move on. Now let's try to use this statement. X square is equal to 25. So if x square is equal to 25, there are two values arising out of it. X can be 5 and x can be negative 5. These two values satisfy the statement. So I'm getting, and over here x is positive, yes, x is positive, no. That means I'm getting a yes, I'm getting a no by combining both the statements. That means this statement is also not sufficient because I'm getting a yes, I'm getting a no. Now it's the turn to combine both the statements. So once you combine both the statements, you need not think about any new values. What you can do is you can use the same value and try using this set of values into this statement and using this set of values in this statement, and then see which all the values survive both the statements. So x is equal to 5. Is this satisfying x square is equal to 25? Yes, it is. X is equal to negative 3. Is it satisfying this statement? No, it's not satisfying. X is equal to negative 5. Is this satisfying this statement? Yes, it is satisfying this statement. Modulus of minus 5 is greater than 0. That means while combining both the statement, my three values survive. This, and this. And out of these values, there is a yes and there is a no. That means that I will not be able to get the answer because even by combining both the statement, I have a yes and I have a no. That means the answer is option E. Option E is the answer when both the statements don't give you the answer. So I hope this is pretty clear to you. Let me just give you a recap. I did it on an easy question so that you understand the premise. So first there is a condition. Now you look at the statement 1 and you pick up a value, pick up any value. Don't think about getting a yes. Pick up a value which satisfies this statement and then see whether the statement is giving you a yes and a no. So I picked up x equal to 5, that gave me a yes. So I should be looking for a no because I'm trying to disprove a statement. Always remember, trying to disprove is always easier than proving. So I picked up x equal to negative 3. So x is equal to negative 3. That means that it's satisfying the statement, but I'm getting a no here. The same thing I did for the second statement as well. And when I was about to collide both the statements, I just used the same values and checked which all values satisfied both the statements. So these three values satisfied both the statements, and I'm getting a yes, I'm getting a no from both as well. That means I will not be able to get the answer even using both the statements. You will see the power of yes-no data sufficiency questions and the power of this technique, because this can solve almost all the questions in very quickly. You just need 4 values, that's it. Alright, that will give you the answer. So what to do when combining statements? Whenever you're combining statements, use the same values, right? And then see which values survive. So if a yes and a no survive, that means both the statements are not sufficient. If only yes survives, that means yes, the statements are sufficient. If only no survives, yes, the statements are sufficient. Alright, so let's try to do some questions so that you understand the premise for it. Alright, so let's see, is x a positive number? He's asking, is x greater than 0? So I have to try getting a yes and try getting a no. If I have a yes and a no, done, my deal is done. So x plus 6 is greater than 2. So from this I can very well say that x is greater than negative 4. Now pick up any number where x is greater than negative 4. Let's say x is equal to 4. 4 is greater than negative 4. Fine. Is 4 a positive number? Yes. I've got a yes. Pick up any other value. X is equal to negative 2. Negative 2 is greater than negative 4. But x is not a negative number. So I have a no. Once I have a yes and a no, that means the statement is insufficient. Now, square of x is greater than 25. Pick up a value where square of x is greater than 25. X is equal to 6. If x is equal to 6, square of 6 is greater than 25. Is x a positive number? No. Yes, it's a positive number. It's satisfying the statement. Pick up another value, x equal to minus 7. If I pick up minus 7 square is greater than 25? Yes, it is. Is x a positive number? No. So I have a yes and I have a no. That means the statement is not sufficient. Now let's try to combine both the statement and let's see what all values survive. So is square of x greater than 25? Square of 4 greater than 25? No. Is square of 2 greater than 25? No. Now let's see that. Is 6 plus 6 greater than 2? Yeah, it is greater than 2. So this is surviving. Is negative 7 plus 6 greater than 2? No. Now this is why I have done this, why I've chosen this values to show that don't blindly go by, okay, these all values survived. Now you have a yes. Now try getting a no. Let's try get a no. Alright, square of x is greater than 25 and x plus 6 is greater than 2. Now this is where you should start thinking algebraically. Because this is where you should think algebra, because this is the path, this is the way you should be starting to think. Why is that? If x is greater than minus 4 and x square is greater than 25, so why is that? Now if x square is greater than 25, that means x is either greater than 5 or x is either less than negative 5. Only these values would satisfy this statement. And over here x is greater than minus 4, that means only these values would satisfy the statement. This would go. That means I'm getting a definite yes. Alright, so I'm getting a definite yes. That means yes, x is a positive number. So we were able to get the answer by just getting a yes, by just trying to get a no. And once we combined both the statements, see, very rarely you'll be combining both the statements, because usually you'll get one of the statements as the answer. So even if you combine both the statements and only one statement survive, still try to get the accurate answer. Still try to find a value. What if you have skipped one of those values, right? So still try to think algebraically. So over here both the statements are giving me the answer. So I hope you're understanding what I'm trying to do here. The yes no data sufficiency part. The premise of the question itself is tricky. Leave alone the question aside. Fine. Let's do some other questions. So when combining both the statements, try to use the same set of values that you've taken for the statements individually. I think we have established that pretty much. So let's move forward. So what values to try? Because see, in this previous I tried 4, I tried minus 2, I tried 6, I tried negative 7. There are lots of values in the whole number system. How can I be quick? How can I be clever about the values to try? So you can always try positive numbers. Alright, you can try negative values. You can try values between 0 and 1. You can try values between 0 and negative 1. These 4 different categories, if you try, that will give you a complete insight. That will definitely give you the answer, mostly. If I try x greater than 0, what's so special about x greater than 0? X cube is greatest, x square is the next, and x is the least one. What's so positive, what's so good about negative values? Means the values which are, let's say, what's so good about the values which are less than negative 1? That's what I want. Not all the negative values, just the values which are less than negative 1. So there are lots of things. Over here 3 is greater than 2, but minus 3 is not greater than minus 2. So these are where the traps are made for those kind of questions. Similarly, values between 0 and 1. Over here x square is smaller than x. There are lots of things different between these values and these values and these values and these values. So if you try these all values and check, you'll definitely find a yes and a no, right? So let's try to use these things and let's try to solve some questions. Okay. Alright. So let's see this question. It says if r is an integer, is r evenly divisible by 3? So what do you mean by evenly divisible? Once you divide it, the factor that comes out should be a multiple of 2. So let's try to find the answer. Let's try to get a yes and let's try to get a no. Alright. So this is the first. So if r is an integer, is r evenly divisible by 3? First statement says 2 into r is evenly divisible by 3. Give me a value for r. Alright. So let's say r is equal to 6. If r is equal to 6, now you know that this is a fact statement. We have to satisfy this fact statement. So 2 into 6 by 3, it's evenly divisible by 3. 2 into 6 by 3 gives you 4. So it's evenly divisible, right? So it gives me a yes, that yes, r is evenly divisible by 3 because r is equal to 6. 6 is evenly divisible by 3. Now let's try to pick up another number. Let's say r is equal to 3. So if r is equal to 3, 2 into 3 by 3 is evenly divisible by 3. However, 3 by 3 is not evenly divisible by 3. So I've got a yes and I've got a no. So you can clearly see 2 into 3 by 3, it's evenly divisible. I get a 2. However, 3 by 3 is not evenly divisible. I get a 1, which is an odd number. Alright. Now let's try to use the second statement. Second statement says that 3r by 3 is evenly divisible by 3. Now give me a number where 3r by 3 is evenly divisible by 3. Let's say r is equal to 6 again, right? If r is equal to 6, 6 into 3 by 3 will be evenly divisible by 3. And the number will also be evenly divisible by 3. I think we should establish that here. Now give me a value where 3r by 3 is evenly divisible by 3. Let's say r is equal to 2. If you put r equal to 2, 3 into 2 by 3, it's evenly divisible by 3 because 3 gets cancelled. I'm only left with 3. Now if you go back to the statement and check, over here r is not even divisible by 3, leave alone when it will be evenly divisible by 3. So that means I have a yes and I have a no. So the statement is also insufficient. Now what should I be trying to do? I should be trying to combine both the statements. So let's see what all statements survive. So this first statement I should be checking whether they survive the second statement or not. So if r is equal to 6, is 3r evenly divisible by 3? Yes it is. 6 into 3 is evenly divisible by 3. If r is equal to 3, is 3r evenly divisible by 3? No, because 3 into 3 is 9. 9 is not evenly divisible by 3. Similarly, if r is equal to 6, we establish that it's evenly divisible by 3. If r is equal to 2, it's 2 into r. That means 2 into, let's say, r. Is it evenly divisible by 3? No, this is not even divisible by 3. So I'm getting a definite yes. Only the yes values are surviving. That means my answer is yes. That both the statement taken together will give me the answer. So you see, we were able to solve. See, it took me time to explain to you, but once I am doing that question, I'm making this graph yes, no. Find a value for yes, find a value for no. Find a value for yes, find a value for no. Combine both of them. Let's see what statements survive. Think a little bit, 5 seconds. Okay, move on. C is the answer. Alright. So this is the way you should be doing this question. So I hope you're understanding. Okay. Alright. So let's see this question over here. Now question is asking, is P positive or not? Right? So the question is asking, is P positive or not? The first statement. So we have to try getting a yes and try getting a no here, right? Similarly, we'll be doing that. So first statement is saying that the square of P is positive. So take P to be 5, P square is positive and P is positive. Take P to be minus 4, P square is positive and P is not positive. So I have a yes and I have a no. Let's check the second statement. Second statement say that modulus of P minus P is positive. So it's greater than 0. So I can say that modulus of P is greater than P. So when it is possible that modulus of P is greater than P, let me try and put a positive value here. I say 4, modulus of 4. Is modulus of 4 greater than 4? No. So the positive values are not sufficing here. What all values will suffice? I think only negative values are going to suffice. So if I put P equal to minus 3, modulus of minus 3 is greater than 3, minus 3. That is true. So that means I'm getting a definite no here. A definite no means my answer is solvable using only the second statement. Right? Why didn't I get a yes? Yes here was because modulus of p is greater than p, which is only possible in negative values. If I put a positive value, they will always be equal, so that cannot be greater. That means my answer is solved by using only second statement. Right? So it's a bit complex, guys, but if you apply this technique, all the students who are scoring in the range of 40s in the GMAT will very well adopt this technique and score a 51, a perfect 51. Right? So let's see this statement over here. Is integer x a multiple of 5? Right? So he's asking, is integer x a multiple of 5 or not? So try getting a yes and try getting a no. Alright, so x when divided by 3 leaves remainder 2. So let's find a number. When x divided by 3 leaves remainder 2, take 5. 5 when divided by 3 leaves remainder 2. Fine, satisfying the fact. Alright, is x a multiple of 5? Yes, it is. X is a multiple of 5 because x is equal to 5. Now let's try getting a no. So how can we get a no? Let's try a number. Okay, 7. Okay, so when x is equal to 7, when 7 is divided by 3, it leaves remainder 1. No, 7 will be not. Let's say any number, 6 plus 2, 8. Yeah. So let's say x is equal to 8. 8 when divided by 3 leaves remainder 2, and 8 is not a multiple of 5. So I have a yes and I have a no. Let's move forward. X when divided by 4 leaves no remainder. So let's take x to be equal to 20, right? So x when divided by 4 leaves no remainder. That means x is equal to 20. 20 divided by 4 leaves no remainder, and 20 is a multiple of 5. Give me a value where I can get a no. Let's say x is equal to 8. 8 when divided by 4 leaves no remainder. That means that yes, 8 is not a multiple of 5, so I have a no. So even by combining both the statements, I'm getting a yes and I'm getting a no. Now let's see what all statements survive. So x is equal to 5 here. 5 divided by 4, does it leave no remainder? No. 8 when divided by 2 leaves no remainder? Yes. So it's surviving. 20 when divided by 3 leaves remainder 2 or not? Divided by 3, it will leave remainder 2. Fine. Okay, hold on. 3 when divided, x when divided by 3 leave remainder 2? No. Yes, it when divided by 3 it leaves remainder 2. So these three values are surviving, and one of those values is yes and one of those values is a no. So I have a yes and I have a no. That means that my statements are not sufficient. So I hope you understood why this value survived. I just checked it with the first statement. When it divided by 3 leaves remainder 2. So this one divided by 3 leaves remainder 2. So I'm getting a yes and I'm getting a no even by combining both the statements. That means both the statements are not sufficient. Right? So I hope you understood this question. Fine. See this question over here. Now in this question, the question says if x is an integer. X is an integer. Now I have to see, is x into modulus of x less than 2 to the power x or not. So I have to try getting a yes and I have to try getting a no. So you see the questions become so easy once you have this technique. You just have to start with getting a yes and getting a no. So once you're not sure, pick up any value in the world and see whether you're getting a yes or a no. So first statement says x is less than 0. Pick up any negative number. Let's say x minus 1. So if x is equal to minus 1, if I put it minus 1 here, it is going to give me minus 1 into modulus of 1, that is 1, and 2 to the power minus 1. So which one is greater? Definitely this value is greater. So I'm getting a yes. Now let's try getting another no here. Let's try getting a no over here. So if you think you will not be able to get a no, you'll try 2-3 values. I know that. Put x equal to minus 2. Still again, minus 2 into 2, will it be greater than 2 to the power minus 2? No. Now why is that? Because a positive number to the any power will always be greater than 0, and this number will always turn out to be negative. So that means I can never get a negative value, a value that is telling me a no answer. right? Because this over here will always be negative and this over here will always be positive. That means this over here will always remain greater, right? So I have a definite yes. That means it's giving me the answer. Second statement is itself saying x is a negative number, so that means also it's also giving me a yes. So from each statement I have a definite yes. That means D is my answer. Alright, so you see, when should we start thinking algebraically? Once we have substituted the values, and then we should be start thinking the algebra part. Why is that? Alright. Okay, now let's see this question here as well. Now again, I'm going to start with the same thing. I have to get a yes and I have to get a no. So over here, modulus of x plus 3 is equal to 4x minus 3. Now let's try to, whenever you get such questions, you should always try to do a little bit of algebra first. So modulus of x plus 3 is equal to 4x plus 3, or modulus of x plus 3 is equal to negative of 4x plus 3, because that's what modulus says, right? It can be either positive, it can be either negative. So I'm sorry, x plus 3 can be this, or x plus 3 can be this, because whatever you put in, positive is gonna come out. So I can say that 3x, this goes this side, is equal to 6 and x is equal to 2. X is equal to 1 value is that. Or I can say that x plus 3 is equal to negative 4x plus 3. That means 5x is equal to 0, x is equal to 0. So x is equal to 2 and x is equal to 0. These are the two values that I should be trying. However, you have to meet the fact statement first. Now let's try to put the fact statements there. 2, if I put 2 plus 3, alright, that is equal to 5. And if I put 2 to this side as well, 4 into 2 minus 3, that is also equal to 5. Fine enough. Let's try putting 0. This is 0 plus 3, that is 3. And this is 0 minus 3, that is negative 3. That means I can't use 0 because it's itself not meeting the fact statement, because as we already discussed earlier that we have to meet the fact statement for us to go and check the condition. So it's not even meeting the fact statement. That means I'm only left with one variable, that is x is equal to 2, which is giving me a yes, right? Are you understanding my point? I hope you are, because it's a very simple scenario. It's just the trick is that you have to meet the fact statement. You can't simply say a yes and a no. So let's move forward. Similarly, if we do this, x plus 1 can be either equal to 2x minus 1, and x plus 1 can be either equal to 1 minus 2x. So from here I get x to be equal to 2, and from here I get x to be equal to 0. Put x equal to 0 here, it won't suffice. 1 equal to minus 1, not possible. Put x equal to 2, it would suffice. That means I'm getting my answer using individually each of the statement. I'm getting my answer using individually each statement. So that means my answer is D. Now if you remember in the previous video I told you that if the answer is D, each of the statements would be giving me the same answer. So over here answer is x equal to 2, and over here the answer is equal to x equal to 2. Fine. So I hope you understood the premise of this technique, the technique that I'm trying to explain. I'll be solving a lot of questions on this technique though, definitely. So if you can never go wrong using this technique. Algebra can lead you to right path, definitely, but there is a probability that it might lead you to the wrong path as well. So what you need to do is you need to try to get a yes and try to get a no. You have your answer. Right? So I hope you understood this, and please give me your valuable feedback on this email address if you have understood the concept completely, because it's very important for me that you understand the concept, right? So this was about the concept video on this. We'll be doing a lot of questions definitely, right? So open up your official guide, go to the last of the data sufficiency questions, okay? And do those questions. There are lots of questions which are based on yes no data sufficiency questions. Okay, so this was about it. Thank you very much and see you next video.